Hi, this is Bentley's mom, and today we're going to go over Chapter 11, Lesson 3, which are the measures of variation, and we're going to learn all these vocabulary words, what they are, and how to find them. We have the range, the median, which you know how to do this one, the quartile 1 or Q1, and quartile 3 or Q3, and what's called the interquartile range. Okay, and these are the notes. And Bentley, if you want to zoom in on these. And I'll go over these as we do the problem. What the range is, and it's in a data set. This is the data set from example 2 in the section. If you have this data, what the range is, you put the data in order. You always put the data in order first. Then you take the largest number, which is 72, and subtract the smallest number. And that's how you find the range. The median is the middle number. So you put the data in order and you go like this. And the median we get is 55. Then for the first quartile, what the quartiles are, it's like a quartile is like 1/4 of something, like there's 4 quarters in a dollar. So when you take the median, you're basically splitting the data in half, where you have the lower half of the data, or lower 50% of the data, or like all the lower half scores are here, and all the upper half or the upper 50% of the data are here. Well, when you find a quartile, what you're doing is you're finding the median again of the lower half. Okay, and out of these numbers, it's going to be 48, which is right here. And then what that does, I drew these dotted lines, so it splits the data in half. And then when you find the median again from the left side, it splits the data in half again. And what that does is it splits it up into quarters or quartiles. So this from here to here, that's the first 25% of the data, then the second 25%, then the third 25%, and then the fourth 25%. So that's what that is. Now to find quartile 3, you find the median basically of the upper half. Okay, and then when you do that, you get 63. So quartile 1 in this case is 48, quartile 3 is 63, and then to find the interquartile range, it's similar to the range in that you do the largest minus the smallest, but for the interquartile range, you're basically doing quartile 3 minus quartile 1. So in this case, it would be 63 minus 48. Which is 15. And those are the notes. So I'm going to take those down for right now. Okay, so I'm going to do example 1 on page 830. And it gives you a data set of 1, 8, 25, 30, 50, and 70. Okay, this is example 1. Okay, so the first thing we're going to do is, okay, are we back? Okay, so the first thing we're going to do, this is example 1, is we're going to find the range. Okay, so to find the range, you're going to take the biggest number, which is 70, and you're going to subtract the smallest number, which is 1. So our range is 69. Okay, then we're going to find the median. So you go like this with your data. Okay, there's 2 here, and these guys tie right here. And let's see. And when there's a tie, what we're going to do is we're going to just find the average of these 2. So how you do that is you do 30 plus 25, which is 55, and you divide that by 2, and we get 27.5. That's the median. Okay, and then, let's see, then what we're going to do, so it's going to be right here. I'm just going to draw in little dotted lines for the median. So that the median here is 27.5. Okay, now we're going to call it Q1, short for quartile 1. We're going to find the median of this lower half. Okay, so we have this one and then this one. And the median is going to be, the first quartile, which is the median of the first half of the data, it's going to be 8. It's Q1. And then we're going to do the same over here for Q3. Okay, so we go like this, and we get 50. It's Q3. Yes.
What happens if there's only one, like there's not, it's an odd amount number, so the median is one number?
Oh, that's okay. If the median's one number, then actually,
Is it just two out?
yeah, you still just do, you don't include the median and you do everything on the right and everything on the
So
left.
if 27.5 was an actual number in the number line, you would skip 25 and 30?
You would, yes.
So it's not 1 over, but
You're
2
skipping the
over?
median either way because we're not really including 27.5. We're just looking at what's left to the right and what's left to the left.
So it's basically 2 left to the median and 2 right to the median?
Well, we'll basically, you take your median out and then you find the median of that, the data on the left. And then take your median out, whatever it is, and then you find the median again with what's left on the right. And we'll do some more examples. That's a great question. Okay, so now we have, I think the last thing is the interquartile range. So I'm going to call that IQR, okay, for interquartile range. And what we're going to do is you take quartile 3, which is 50, and we're going to subtract out Q1, which is 8. Okay, and so we get 42. Okay, and I believe that's all for example 1. So turn the page.
I have another question
Yeah,
on
go
that.
ahead.
Do you just minus 50? Do you just minus the big number to the small
Yes,
number?
that's what
or
the
is
range
it,
is.
Or is it okay?
So what the range is, the normal range is always the biggest number minus the smallest number. Oh, you know what? Yeah. Oh, sorry, not 8. So
Like,
70 minus 1,
Yeah.
which is 69. But what the interquartile range is, it's the same thing. It's always the largest number minus the smallest, but you're doing the quartiles, not the data. So this is a small set of data, but for the interquartile range, you're doing Q3, which is the bigger one, minus Q1, which is the smaller one. It's always, range is always the largest one minus the smallest one.
So you're basically always minusing quartile 3 to quartile 1.
Because basically what you're
because
seeing
quartile 3 is always bigger
is
than
how
quartile
much does the
1.
data range? How many spaces on the number line are between 8 and 50?
2.
And no, between 8 and 50. To do that, you
That's a lot.
subtract. That's how you get 42.
Oh.
So there's a spread or a variance of 42 between 50 and 8. Okay, does that make sense?
Mm-hmm.
Okay, we'll do some more examples. So, all right, now we're going to do example 2. So turn the page. And let's see here. I'm on page 831. So it says the ages of the candidates in the election, and it lists out the ages. So I'm going to put them in order for you. We have 23, then we have 48, then we have 49, then we have 55, then we have 57, 63, and 72. Okay, so that's our data set. Let me just I'm going to count it and make sure. There were 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Okay, so the first thing I'm going to do is I'm going to actually go through all of these things, and I'm going to show you how to find the outlier. And finding the outlier is pretty difficult. So let's walk through this slowly. So the first thing I'm going to do is just find the regular range, just to make sure you know how to do that. So we're going to do 72 minus 23, okay, and I get 49. Okay, and I don't think they asked you in this question, but they will. I just want to make sure you know how to do all of these things for any set of data. Okay, the next one is the median. So to find the median, okay, we're going to count like this and get the middle score. So this one you go 1, 2, 3, 1, 2, 3. So this one right here, I'm just going to draw a dotted line. This is our median, which is 55. Okay, and then we're going to find Q1, or quartile 1. So we're going to basically go to the lower half of the data, and we're not going to include the median. Okay, so out of these numbers, what's the middle one is 48, and that's called Q1. Okay, and then we're going to do the same thing to the upper half of the data. And we're gonna kind of put our hand over the median. We're gonna find the median of the upper half of the data, which is not called the median, it's called Q3, okay? Or quartile 3, which is 63. Okay? Then the next thing we're gonna do is find what's called the interquartile range. Okay, and if you guys remember how to do that, I'm gonna call it IQR. You're gonna subtract Q3 minus Q1. So we have 63 minus 48. Okay, and we get 15. Okay, now that is what all of that is. Now, the last thing that we have to find out is how to find out what the outlier is. Okay, now, if you can get all of this, what's on the board right now, you're in a really, really good place. Technically, finding the outlier is really difficult. In general, what an outlier is, it's a number that's far away from the data set. Okay, so if I have a whole bunch of numbers like 2, 3, 4, 2, 3, 1, like really small, and then I have a number like 525 that's nowhere near the rest of the data, that's called an outlier. So how I say it is it's kind of like outlined by itself, you know, way, 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 way out there. So like if I gave a test and let's say a student was absent for 2 weeks and, you know, didn't do any of their work, and so when they took it, they got a really, really low score, like 5%. But all the rest of the class maybe got 82 or 85% or 92%. Because they didn't make up the work, they were very, very far, you know, getting like a 5% on a test was far away from the rest of the data. That would be called an outlier. Now, to find it, just looking at it, for elementary math, if you're kind of looking at it going, okay, is there a data that's really far away from the data set? Looking here, it's going to be either one on this side or one on this side. Now, it's hard to kind of tell, well, what do you mean by exactly far away? So looking at this, 72, okay, that's kind of far away from 63, but 23, that's even more apart from 48. You could have two outliers. You could have one here and one here. But mathematically, this is how you know, is this far enough from 48 to call it an outlier? Is 72 far enough from 63 to call it an outlier? So specifically, this is what you do. To find the outlier, the outlier has to be 1.5, okay, times the interquartile range, or the IQR, okay? So what you do is you find the interquartile range, which in this case is 15, and you multiply it always by 1.5. So it has to be 1.5 times away from the interquartile range. And that's what statistically in higher level math is considered the outlier. So we're going to multiply this, and 1.5, let's see, give me 1 second. If I'm doing this right. Here, stop it really quick, because I'm going to do a separate section on the outlier. So stop it and then we'll go on.